This is GCSE further maths, mechanics. We're doing connected particles. Just started pulley systems. This then as example 2. So this is a tougher one. There's a lot going on in this question that we look at. Two blocks P and Q of mass 7 kilograms and 5 kilograms are connected by a light inextensible string passing over a smooth pulley. Blocks are held so that both parts of the string are vertical and P is 12 meters above the ground. Blocks are released from rest, assuming Q does not hit the pulley. Calculate the acceleration of Q and the speed of P when it hits the ground. When P hits the ground, the string will be slack and Q will initially continue to rise. Calculate the additional distance by which Q will rise after P hits the ground and the time that elapses between P hitting the ground and the string becoming taut again. So there's a fair bit going on there. So let's make a start then on this one. So let's see if we can take down the first bit that we need. So let's get a wee diagram drawn first of all. Here's my pulley. And I have R2 that is acting. So I have a 7 kilogram one, which I think is P, and then a 5 kilogram one, and we're told that that is 12 meters from the ground. Up in a wee second. What forces do we have acting on? Just the same as our last time. So we have 7G, and then we have 5G. We have a tension here, and again I haven't put on the ones in the pulley. It's going to accelerate this way here, and of course this way here. Let's do F equals MA then for both of these, and we'll see how we go. So first of all, for the 5 kilogram one, we do F equals MA. Let's see if I can get a decent bit of light here so we're not. See, that's okay. So for the 5 kilogram one, it's going this way. So it's going to be T take away 5G equals MA. T take away 50 equals MA. For the 7 kilogram one, again, F equals MA. Let's take a look at it. 7G take away T. Sorry, that should be a 5A. I'm not sure what I'm doing here. Equals 7A. 70 take away T equals 7A. Listen, we'll just do this one a slightly different way so we can see where it comes from. If I rearrange this to get the T on its own, that means T equals 50 plus 5A, and the T here is my 70 minus 7A, and then let the two of them equal each other. That means 50 plus 5A equals 70 minus 7A. I would add, of course, 7A to both sides, so I would get then 12A and take 50 from both sides equals 20. A is 20 over 12, which cancels down into 5 over 3 meters per second squared. So that's the acceleration. That's what we needed then to start with. Find the speed of P when it hits the ground. I'm going to have to use UVAS then for this. U, V, A, S, T. It starts from rest, so it's 0. It's 5 over 3, that's 1 2/3, and my distance then is 12 meters, and we're trying to find V. We have U, A, and S, so we're going to be using V squared equals U squared plus 2A. S. V squared equals 0 squared plus 2 upon 5 over 3 upon 12. That means we have V squared equals 40, and V then is root 40, which is 6.3245 or 6.32 meters per second, That's into 2 decimal places. Part 3. When P hits the ground, the string will be slack and Q will initially continue to rise. Calculate the additional distance by which Q will rise after P hits the ground. The time that elapses between P hitting the ground and the string becoming taut again. Can you see what's going to happen? So this kind of speeds up until it hits the ground. Whenever it hits the ground, the string becomes slack and then the 5 just bounces up a wee bit, and that's what we're trying to find. We're trying to find that bit bouncing up a bit. So whenever that happens, we need to try and work out how high it goes. Now, whenever that happens, whenever it becomes slack, the T disappears. So it's just like me throwing something up in the air with a speed of 6.32 meters per second and seeing how far it goes. So that's what's going to happen. So let's take that down just as a wee statement, and then we'll try and do the sums for it. It's quite a tough one. When string slack, it is ignored. And the particle is just moving under gravity. Let's just talk about that again before we actually do the sum. This heads up in the air, this hits the ground. If this hits with a speed of 6.32, then this is going at 6.32, and it's as if I have it in my hand and throwing a 5 kilogram thing up in the air with a speed of 6.32 and want to see how high it goes. So U, V, A, S, and T. U is 6.32455. I actually like using root 40 there. If you can, it keeps things a bit more accurate. That's the exact answer which we have. V is 0 because we want to know how high it goes, and my gravity then is minus 10. We know that from unit 1. So we're going to use V squared equals U squared plus 2A. S 0 U squared, that's just going to give me 40, so we're now back to have it exact, plus 2 upon minus 10 upon S. Well, we just get S, sorry, we get 20S is 40, and S then is 2 meters. So what's going to happen now? This is going up in the air, it's going up another 2 meters, and then it's going to come back down again. And whenever it comes back down again, the string's going to get taut. So we want to find the time then that it gets taut again. So let's take that down as a statement, and then we'll do the sums. We're getting there. String taut again when Q returns to point it was when P hits ground. There's a wee diagram here if you want it. So here's where we are. We have our pulley. P has hit the ground and Q is bounced up in the air again. It's kind of gone up and going up again. It's gone up 2 meters and then going to come back down. So find the time up and down is what we need to do. So we're going to just find the time up and then double it. So it'll just be kind of symmetry from there. Now we have the information. This is the information we need. So if we just find that T there, that's going to be the same, and that's what we'll want. So we're going to do V equals U plus AT. 0 equals 6.32455, or if you want root 40, plus minus 10 upon T. 10T is 6.32455. So my time then is 0.632455. Nearly there. Therefore, time elapsed is 2 times 0.632455, which is 1.26491. and the 2 decimal places 1.26 seconds. That's the 2 decimal places.